In this video, we're going to be discussing pumped hydroelectric power stations or pumped hydroelectric power plants, and we're going to be looking at some of the potential environmental and ecological impacts associated with their use. We're going to use the example of Coo-Trois Ponts, which is actually based in Belgium. So here we have a photograph of Coo-Trois Ponts, and what we see is we have two upper reservoirs which are used to deliver water into a lower reservoir. Now, with it being a pumped hydroelectric power station, when there's an excess of power being generated on the grid, water is pumped from the lower reservoir through tubes up to the upper reservoir. And when the demand for electricity on the grid is higher than what's being supplied, the water is released from the upper reservoirs back through the pipes and through the pumps, which will now be acting as turbines. And that's going to produce electricity back to the grid. So before we consider some of the impacts associated with this, let's first of all consider some of the benefits. Now, one of the challenges of generating electricity through renewable sources is storing that energy. It should be apparent that things like wind energy and solar energy are somewhat unpredictable. At times we can produce an abundance of energy, and at other times there's a shortfall in our requirements. So energy storage is going to be a huge focus in the future as we convert more of our energy production to renewable sources. And there's actually relatively limited technologies for storing electricity. So that's the first benefit of this type of station. Another huge benefit is that we can deliver on-demand power. So here in the UK, the National Grid is responsible for monitoring usage on the grid, and then they would actually contact power stations to either increase or reduce their production of electricity. The huge advantage with this type of plant is that it can provide that on-demand electrical power. And in fact, Coo-Trois Ponts can provide up to 1200 megawatts of power for up to 6 hours. Now, just to put that into context, that's roughly the same power production of a nuclear power station. Or as another example, the largest offshore wind turbines of this time are 10 megawatt machines. So this can provide the same amount of power as 120 of the biggest offshore wind turbines. And don't forget that wind turbines don't always produce their rated power. It has to be certain wind conditions for them to produce their 10 megawatts. So this power plant has the potential to produce a huge amount of electricity on demand. Now, another huge benefit is that this is clean energy. We're not burning any fossil fuels, we're not producing any carbon dioxide. But nonetheless, there are still some ecological and environmental impacts. The first thing to consider is the impact this might have on fish migration. The way that the lower reservoir was created here was by damming the natural flow of a river. So that's obviously going to affect the flow of the river and potentially the creatures living in and around the river. Another potential impact is over land use and habitats. The two upper reservoirs we see here are man-made. We can see around the outside that there's forest area, so the likelihood is there's been deforestation in order to create these two upper reservoirs. By doing so, the likelihood is that some habitats have been disrupted as a result. So this is obviously an important consideration when constructing a new power plant of this type or any other type. Another potential impact is the impact that this has on the temperature of the water. When the water is delivered through the pumps or returned through the turbines, that's actually going to cause the water temperature to increase. So these are all things that need to be considered. Now, generally, when new technologies are being considered for a new site, an environmental impact assessment will be carried out in order to look at all of the possible impacts and then weigh those up against the potential benefits. And that's exactly what I want to encourage you to do. Because if we look at impacts in isolation, it would be easy to put forward an argument as to why the development of this plant should never have gone ahead. But if we consider the benefits and we consider the alternatives, then that's likely to sway the opinion in the favour of developing such plants. So what are some of the alternatives to pumped hydroelectric power? Well, as mentioned earlier, one of the challenges we face is storing energy. And there are very few technologies for storing energy. But what we do have is technologies for producing on-demand power. Some of the different technologies that are available are nuclear power as an example, and we also have biomass plants. Biomass is a carbon neutral crop which absorbs carbon dioxide when it grows and then releases that carbon dioxide when it's burned. So it's what we call carbon neutral. Some of the more traditional alternatives are things such as our gas-fired and our coal-fired power plants. The advantage of these types of plants is when demand increases, we can simply burn more fossil fuels. It should be apparent that there's impacts associated with that as well, because then we're producing carbon dioxide, which potentially has a damaging impact on the environment also. So in this video, we've talked about some of the benefits of pumped hydroelectric storage plants, and we've also considered some of the impacts. Hopefully by considering the alternatives, it will help to stimulate some thought and enable you to evaluate whether you believe that pumped hydroelectric storage is beneficial or whether the environmental and ecological impacts outweigh the potential benefits.